Now we're going to look at the absolute value equations that are in this section. First of all, an absolute value. Notice that an absolute value cannot equal a negative value. Okay, so an absolute value cannot equal a negative. What's inside could be a negative, and when you take the absolute value of it, it becomes a positive because it's about distance. So for an equation here, if the absolute value of x is equal to 7, then x could equal -7, and x could also equal +7. So there are two possible solutions when you're looking at this. So I might do this a little differently than you're used to, and that's really because when you look at inequalities, it kind of helps make sense of things with inequalities. So solving equations with absolute value, one of the most important things is that you have to isolate the absolute value first. That doesn't mean that you can simplify and distribute inside the absolute value. You have to isolate the absolute value. So once you have your absolute value isolated and you have everything over on the other side, then is when you can solve it 2 times. So here's where mine might be a little different than what you're used to, because the second time I solve it, I take the opposite of what is inside the absolute value. So the second time I solve it, I take the opposite of what is inside the absolute value. Always here. Now, normally we say things like, can you always check your solution? Yes, you can always check your solution. It's really important that you check your solution. At least with MyMathLab, it is checking your solution, so you can kind of catch yourself if you are making a mistake. But again, check your solutions. You have a calculator. Just make sure that you know how to check your solutions when it comes time for a test. Let's look at our first example here. Solve the absolute value equation or indicate that the equation has no solution. I have the absolute value of x plus 3 is equal to 8. So is that absolute value by itself? Yes, that absolute value is by itself. Now I'm going to solve 2 times. First time, I'm just going to drop my absolute value. X plus 3 is equal to 8. The second time, I'm going to write the opposite of x plus 3 is equal to 8. Solving my first equation, subtract 3 from both sides, so I have x is equal to 5. My next one. Now, can you solve this one a couple different ways? Yes, you can. However, a lot of times do we just say, well, I'm just going to go ahead and divide by a -1, since I can divide by a -1 on both sides, and I get x plus 3 equals -8. Then subtract 3 from both sides, so I get x is equal to -11. Check my solutions. Just plug them in. 5 plus 3, 8. The absolute value of 8 is 8. -11 plus 3 is -8. The absolute value of -8 is equal to 8. So my solution is then -11 and 5. There's 2 solutions that I have there. Let's look at number 6. Is my absolute value by itself? No, my absolute value is not by itself. The first thing I need to do is isolate my absolute value. Subtract 4 from both sides. 3 times the absolute value of 2x plus 6 is then equal to 6. Now I still have this 3 that's on the outside of my absolute value. I cannot distribute that in the absolute value. I can, though, divide both sides by 3. Once I divide both sides by 3, then I have the absolute value of 2x plus 6 is equal to 2. Once I'm here, then I have my absolute value equals everything else on the other side. I've isolated my absolute value. Now I can go ahead and solve this 2 times. The first time, I just dropped my absolute value. 2x plus 6 is equal to 2. The second time I solve it, the opposite of 2x plus 6 is equal to 2. So now here I'm going to subtract 6 from both sides. So I have 2x is then equal to negative 4. Divide both sides by 2. X is then equal to negative 2. Can I distribute my negative sign in here? You can. Will you get the same answer? Absolutely, you will get the same answer. A lot of times we just remember that we have to flip that sign. We have to solve it twice, once with a positive and once with a negative. I like to do it this way because it really is talking about the definition. What's inside the parentheses actually could be a negative. That's the key, is that it could be a negative. But I'm going to go ahead and here divide both sides by negative 1. So I get 2x plus 6 is equal to negative 2. Subtract 6 from both sides. 2x is then equal to negative 8. Divide both sides by 2. I get x is equal to negative 4. Check my solutions. Plug them in. Make sure that they work. When I plug in a negative 2, I get negative 4 plus 6. So I get 2 inside there. The absolute value of 2 is 2 times 3 is 6. Plus 4 is 10. So it works out. And it doesn't take much to just say, oh, can I check my answer? So in here, both of my answers work. My solutions, negative 4 and negative 2. Let's look at this last one here. Number 7. Isolate my absolute value here. I'm going to subtract 8 from both sides. 4x plus 5, the absolute value of that is then equal to negative 5. So once I get to this point, a lot of times we just keep on going. So once I have my absolute value isolated, I drop my absolute value. 4x plus 5 is equal to negative 5. And then the opposite of 4x plus 5 is equal to negative 5. Solve here. Subtract 5 from both sides. I have 4x is equal to negative 10. Divide both sides by 4. I get x is then equal to negative 5 halves. Solve on this side. Divide both sides by a negative 1. I have 4x plus 5 is equal to 5. Subtract 5 from both sides. I have 4x is equal to 0. Well, then I get x is equal to 0. Now I'm going to check my solution here. So I'm going to check my 0 because it's easier for me to check. So if I plug in 0 into my original, 4 times 0 is 0, plus 5 is 5. My absolute value of 5 is 5. Then it says plus 8 equals 3. Does 5 plus 8 equal 3? No. Okay. Same thing here. If I try to plug in my negative 5 halves here, I get 4 times negative 5 halves, which winds up being negative 5 times 2 when I divide out my 2 and my 4. I get 2. So then I have negative 10 plus 5, which is negative 5. The absolute value of negative 5 is 5 plus 8 equals 3. Still no. Okay. That's because when I actually stop right here, this part right here is a false statement. I cannot have an absolute value equaling a negative. Since I cannot have an absolute value equaling a negative, my solution here is no solution. Can you use this as your answer? Yeah, you might see that. Just make sure that you don't write zeros like that. You're some of you aren't doing a test on paper, but if the answer happens to be 0 and you give me something that looks like that, not all of your zeros look like that, then it's the wrong answer. That symbol does represent no solution. A lot of times in MyMathLab, you're choosing no solution here. Also, going back to the original right up here, I can't have something positive plus 8 that's going to equal 3. So the original statement is a not untrue statement. Can never be true. Awesome. Well, that's it for 1.6. Good luck on your homework.